This video provides an introduction to the unit circle. So if we look at this first diagram here, a unit circle is a circle with radius 1. Okay, so you can see my radius 1 all the way across here. That means that this coordinate here is 1, 0. This coordinate here is 0, 1. This coordinate here is -1, 0, and this coordinate here is 0, -1. So we have that radius of 1. Now, if I pick a point on my unit circle, the point P, that's the point XY, meaning that this here is X and this here is Y. Okay. I could represent that point in terms of an angle theta. So this line here has a length of 1 because it's a unit circle, so it's a radius of a circle, and it's theta degrees rotation in the anti-clockwise direction. So if I now look at that right-angled triangle that I have, and I'll even draw it out here so you can see what I mean. That's a right angle. This is theta. This is my y. This is my x. And that's my 1. If I label that triangle using my trigonometry, my right angle trigonometry, opposite my right angle is hypotenuse, opposite my angle is opposite, and my other side is adjacent. Now, using SOHCAHTOA, sine theta is opposite over hypotenuse. So on my triangle, my opposite was my y, and my hypotenuse was the 1. Well, y over 1 is just y. So that means my sine theta is y. So my y coordinate is sine theta. Cos theta is adjacent over hypotenuse. Go to my triangle. Adjacent is x. My hypotenuse is 1. So it's x over 1, which is just x. So my x coordinate anywhere on this unit circle is going to be given by my cos theta. So if I know what my angle is, I can work out what my x coordinate is. Tan theta is opposite over adjacent. So looking at that triangle, opposite is y, adjacent is x. So tan theta is y over x, but y is sine theta. And x is cos theta. So that means my tan theta is given by sine theta over cos theta. So no matter where I am on my circle, I can work out what my x value is by working out cos of theta, as long as I know the angle, and my y value is given by sine theta. Now, the other thing to note when we're looking at this unit circle is what quadrant I'm in. Remembering that we go in anti-clockwise direction. So this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So in quadrant 1, x is positive and y is positive. So that means sine theta is going to be positive, cos theta is going to be positive, and tan theta is going to be positive. So all ratios in my first quadrant are positive. If I look at my second quadrant, my x coordinate is negative. So if we look at our second coordinate, because we're to the left of 0, 0, x will always be negative, but y will be positive. So that means my x coordinate is cos theta. So my cos theta is going to be negative. Sine is my y, so my sine theta is going to be positive. Tan is sine over cos, So a positive divided by a negative is a negative. So in my first quadrant, all ratios are positive. In my second quadrant, only sine theta is positive. Now let's move to our third quadrant. In our third quadrant, x is negative and y is negative. Any coordinate in the third quadrant has an x value that's negative and a y value that's negative. So that means my cos theta is going to be negative. My sine theta is also going to be negative. But because tan is sine divided by cos, a negative divided by a negative is a positive. So in my third quadrant, my tan ratio is going to be positive. Finally, in the fourth quadrant, my x is now positive because all these values to the right of 0, 0 is positive, and my y is negative. Any coordinate down in my fourth quadrant has an x coordinate that's positive and a y coordinate that's negative. So that means my cos theta, which is my x coordinate, is going to be positive. My sine theta, which is my y coordinate, is going to be negative. And my tan theta, because it's sine divided by cos, is going to be negative. So let's summarize that. So as you can see here, in my first quadrant, cos is positive, sine is positive, right? And you can see that with the triangle. Positive, positive, cos is positive, sine is positive. So that means my tan theta is also positive. Okay, so all ratios are positive in my first quadrant. Second quadrant, we have a negative x and a positive y. So my cos theta is negative and my sine theta is positive. Okay, and our tan theta, which is sine over cos, positive divided by negative, is a negative. So in my second quadrant, sine theta is positive. In our third quadrant, you can see the triangle, negative and a negative. So that means my cos theta is negative, my sine theta is negative. So my tan theta, which is sine over cos, negative divided by a negative, is going to be a positive. So my third quadrant, tan theta is positive. And in my fourth quadrant, we have our x is positive, but our y is negative. So cos theta is positive, sine theta is negative, and our tan theta is going to be sine over cos, negative divided by positive, so it's negative. So in our fourth quadrant, cos theta is the positive ratio. So all ratios positive in the first, sine theta positive in the second, tan theta positive in the third, and cos theta is positive in the fourth. So we have all, sine, tan, and cos in terms of positive. Another thing to note, angles are formed by moving anti-clockwise around the circumference of the circle. They're going to be positive. So if we're going in this direction, we're going to be dealing with positive angles. Angles formed by moving clockwise are going to be negative. So if I go in this direction, we're going to be dealing with negative angles. And all angles are expressed in terms of the acute angle between the x angle and the angle ray. So what that means is we're always dealing with the first quadrant. So to summarize that, if we are going in an anti-clockwise direction, we're dealing with positive angles. At our x-axis, that's 0 degrees. We haven't gone anywhere. Up at this point, which is our 0, 1 point, that's 90 degrees. At our -1, 0 point, we're at 180 degrees. at our 0, -1 point, it's 270 degrees, and then we're back at 360 degrees. And the theta that we deal with is always there. Okay, so if we're in our first quadrant, we're dealing with theta. If we're in our second quadrant, if I know what this theta is, then this angle here is going to be whatever 180 degrees minus theta is. So that angle there is 180 minus theta, because all the way around is 180, but I want to go 180 minus theta. Okay, if I go all the way around to my third quadrant to here, that's going to be my 180 plus theta, all the way around 180 plus an extra theta. So you can see how I've written these here. So yeah, second quadrant's 180 minus theta, third quadrant's 180 plus theta. If I'm in my fourth quadrant, I'm starting here going all the way around to that ray. So it's going to be 360 minus what my theta is. Okay, the other thing we noted was all our ratios are positive in the first quadrant, sine is positive in our second quadrant, tan is positive in our third quadrant, and cos is positive in our fourth quadrant. So that's what we call our ASTC rule, which you might want to remember as all stops to Calliope, for example. My Year 11s have come up with a nice, interesting mnemonic for that. So however you want to remember ASTC, remember we go in the anti-clockwise direction. So let's apply that. So here we've got, where applicable, write each of the following using its reference angle and state whether they are positive or negative. So cos 52 degrees. We're in our first quadrant, so cos is positive. So this is the same as cos of 52. It's no different. We can't change it. And cos is positive in our first quadrant. So my answer is P for positive. Sine 127 degrees. Well, 127 degrees, remembering we have 0, 90, 180, 270. First quadrant, second quadrant, third quadrant, fourth quadrant. So sine 120 means we're in our second quadrant. So sine in our second quadrant is positive, and that's from our ASTC rule. So in our second quadrant, we want to write it in terms of 180 minus our angle. Now 180 minus what gives us 127? That's 53 degrees. So that means I can rewrite this, because it's still positive, as sine of 53. So sine of 53 will give me exactly the same answer as sine of 127. And you can go to your calculators and check that out. Make sure that you see that sine of 127 is exactly the same as sine of 53. So if you go to your calculator and type that in, sine of 127 is approximately 0.80, and sine of 53 is the same. So go to your calculator and verify it. Tan of 347 degrees. 347 degrees means we're in our fourth quadrant. So that means tan is going to be negative. So in my fourth quadrant, I want to rewrite it as 360 minus theta. So 360 minus what gives me 347. That's what I'm trying to work out, because I want it to be a first quadrant angle. And that would be 13 degrees. So because it's negative, we can rewrite it as negative tan of 13. Again, go to your calculators and type in tan of 347, and you'll see that it's approximately negative 0.23. Then type in tan of 13, and you'll get positive 0.23. So you can see that tan of 347 is equal to negative tan of 13. Pause the video and have a go at the next few. So sine of 250 degrees, 250 degrees we're in our third quadrant, and sine will be negative. In our third quadrant, we want it to be 180 plus something. So 180 plus what gives me 250? That's 70 degrees. Sine is negative in our third quadrant, so it's negative sine of 70. Okay? One thing I realized I haven't been doing is writing whether they're positive or negative. So that one was positive, that one's negative. This one's going to be negative. So again, check it out. Put it on your calculator and verify that your answer is correct. So on your calculator, type in sine of 250 and you get approximately negative 0.94. Type in sine of 70 and you'll get the positive of that. Next one, cos of negative 27. Negative 27 means that I'm going clockwise. So I'm in my fourth quadrant. So cos is going to be positive. So in terms of our first quadrant, it's just going to be equal to cos of 27. And again, go to your calculator, type in cos of 27, and you'll get approximately 0.89. Type in cos of negative 27, and you'll get the same answer. So verify that you're doing them correctly. Final one, tan of 260. That's going to be in our third quadrant. So tan is positive in our third quadrant. And again, I forgot to write that this is going to be P for positive. So in our third quadrant, we want it to be in terms of tan of 180 plus something. So 180 plus what gives me 260? It's going to be plus 80. So this is going to be exactly the same value as tan of 80. And it's going to be positive. Again, verify, work out what tan of 260 is on your calculators, and you get approximately 5.67. Then go tan of 80, and you get the same answer. Final one, if theta is acute. So that means we're in our first quadrant. Determine the value of theta. So we want to rewrite these in terms of our first quadrant. The things to remember: in our first quadrant, we have theta. In our second quadrant, we have 180 minus theta. In our third quadrant, 180 plus theta. And in our fourth quadrant, we have 360 minus theta. We also have our all stops to Calliope Rule, meaning all are positive in our first, sine is positive in our second, tan in our third, and cos in our fourth. So when I look at sine of 170 degrees, I say to myself, I am in my second quadrant. So sine in my second quadrant is the only ratio that's positive. So I want to rewrite this as sine 180 minus something because I'm in my second quadrant. 180 minus 10 is 170. So in the equivalent angle to 170 degrees, this is what this is saying. So if I start here and I go all the way around 170 degrees, so this is my line. What I'm trying to do is work out what is that angle there, because that will be the equivalent angle, the equivalent acute angle in my first quadrant. So sine is positive in my second quadrant, so it's going to be equivalent to sine of 10. So therefore, theta equals 10 degrees. In my next one, cos of 230 degrees. Okay, 0, 90 degrees, 180 degrees, 270 degrees, 360 degrees. So for 230 degrees, I'm in my third quadrant. And in my third quadrant, cos is negative. So in my third quadrant, I write them as cos of 180 plus something. 180 plus 50 is equal to 230. Cos is negative in our third quadrant, so it's negative cos of 50. So theta is 50 degrees. Last one, tan of 345 degrees. We are in our fourth quadrant. So in our fourth quadrant, the only ratio positive in our fourth quadrant is cos. So that means tan is negative. So we want to rewrite this as tan 360 minus something. 360 minus 15 is 345. Tan is negative, so it's equal to negative tan of 15. So therefore, theta is equal to 15 degrees.